Okay, part H, x equal, because it's another video of sorry, parametric curves. It's another video of parametric curves. Um Video part 3. X equal cosine h minus t, y equal sine h minus t, and they gave us the domain, which is t belongs from 0 to pi. We have two endpoints here. Let's find those. We don't have limits done because we have equal point, closed interval at points. X of 0 is cosine pi minus t, pi minus 0, it's pi. Cosine pi is minus 1, and y of 0 is sine pi minus 0, which is sine pi, and sine pi is 0. Then we have a point here, which is minus 1, abscissa 0 ordinate. Then x of pi, the other point, the other endpoint, is cosine pi minus t, pi minus pi, because t is pi in this case, so cosine 0, and cosine 0 is equal to 1. Y of pi is equal to sine 0, and sine 0 is 0. We have another point, another endpoint, abscissa 1, ordinate 0. So what do we have here? We have 2 points, endpoints, very important points. Let us circle them or frame them in red, because we need them at the end when we sketch the graph. Now we find the first derivative. First derivative is y dot over x dot, and we did that before. Let's find y dot. Y dot is equal to the derivative of sine pi minus t. So it's cosine pi minus t times the derivative of pi minus t, which is derivative of minus t, because pi is constant, which is minus. And x dot is the derivative of cosine, right? Pi minus t is minus sine pi minus t, and times the derivative of pi minus t, which is minus 1, and it will be plus. In this case, the y dot is minus cosine pi minus t over x dot, which is sine pi minus t. The answer is minus cosine divided by sine. It's cotangent pi minus t. Now, here is very nice, and it's simpler than the previous exercise, because we just have two places to worry about. Because my domain is not from 0 to 2 pi. It's not full revolution, it's half revolution, so it's from 0 to pi only. It's given as that. From 0 to pi by 2, it's all are positive. From pi by 2 to pi, all of them are sine only is positive, and the other trigonometric ratios or functions are negative. This means y prime, which is minus cotangent pi minus t, which is equal minus cotangent pi minus t. This is the derivative, right? This is the derivative. If t is between 0 and pi, 0 and pi by 2, okay? The t, here we have to be careful. The other one was directly cotangent t, but here it's not cotangent t, it's cotangent pi minus t. So the t is, if t is between 0 and pi by 2, any value between 0 and pi by 2 makes this value, right, pi minus t. Pi minus t. If t is 0, if t is between 0 and pi by 2, for sure all of them are positive, right? All trigonometric functions are positive. But what we have here, if we have t0, so we're talking about cosine pi, and if t pi by 2, we're talking about cosine pi over 2. So all the values are between pi and pi by 2, not in the first portion. So it is in the second quadrant, in the second portion or quadrant. So only the sign is positive, then the cotangent is negative, then the derivative is negative, but the derivative is positive, because cotangent negative multiplied with minus, then we have a negative derivative. Negative derivative, this means at this part from 0 to pi by 2, the function is decreasing. Y prime again is equal to minus cotangent pi minus t, right? And now t is between pi over 2 and pi, between pi over 2 and pi. If we put pi over 2 instead of t here, it will be pi over 2, and if we put pi, it will be 0. So I'm working between pi over 2 and 0, so it is in the first portion, which all of them are positive. Multiplied by minus, then it will be also negative. Also negative. No, I did something wrong. I think so, because this we said it's negative times negative. Then this one should be positive, right? We did something wrong here, right? So this one is positive because the cotangent pi minus t is negative multiplied with minus, so it will be positive. This part will be negative derivative. That's great. We got the sign of the derivative. Then we do what? Let's see what's happening at 0 and at pi over 2. At 0 and at pi over 2. Let's see what's happening at this point and this point, at t equals 0 and at t equal pi over 2. What's happening for whom? For the derivative. Okay. If y prime, if t0, if t equals 0 or t equal pi over 2, that makes the minus cotangent pi minus t. If t0, it will be cotangent pi, and cotangent pi is 0. And if it is pi by 2, it will be cotangent, again, why I put t equals 0, I don't know. At t equal pi over 2 only. At t equal pi over 2 only. All right? So what's happening at t equal pi over 2? It's not at 0. At 0 and at pi, not at 0 and pi by 2. If t is only pi by 2, right? If t only pi by 2, what this will be? This will be minus cotangent pi minus pi by 2, so it's cotangent pi over 2. Cotangent pi over 2. What happens at pi over 2? The cosine is 0, and the cotangent is cosine over sine, so it will be also 0, and that is the derivative, right? That is the derivative. So derivative 0, what's that mean? This means at point t equal pi over 2, we have horizontal tangent. Now, if, let's say, t equals 0 or t equal pi, this means the derivative, which is minus cotangent pi minus t. If I put t0, it will be cotangent pi, and if I put t pi, it will be cotangent 0. What happens for the sign at 0 and the pi? The sign at 0 and pi is 0, and the cotangent is cosine over sine, so we have 0 in its denominator. This means it tends to infinity, and if the derivative tends to infinity, this means we have vertical tangent. Where we have vertical tangent, we have at t equals 0 vertical tangent, at t equal pi another vertical tangent. Let's see what happens as next. I think so the time also will not be enough. We should find the second derivative, right? The second derivative, we know that the second derivative is equal. The second derivative is equal to y2 dots x dot minus y dot x2 dots divided by x dot to the power 3. So let's find y2 dots, and if this is y dot, what is y2 dots? The derivative of this, right, is equal to derivative of cosine pi minus t. This is minus first, and the derivative of cosine pi minus t is minus sine pi minus t. So this will be plus now, but we have u pi minus t, its derivative is minus, so it's minus again, and the derivative of x dot is minus cosine pi minus t, because it's cosine pi minus t times the derivative of minus t. So the cosine, the x dot is minus cosine pi minus t, and the y2 dots minus sine pi minus t. Let's see what will happen here. The y2 dots is minus sine pi minus t, minus sine pi minus t, times the derivative of x dot, which is sine pi minus t. This means we will have minus sine squared pi minus t, minus y dot is minus cosine pi minus t multiplied